Episode 74, NIH Director and former leader of the Human Genome Project, Francis Collins. Welcome to The Art of Excellence, a show about people doing extraordinary things in their lives. I'm your host, Glenn Zweig. Thanks for joining me. My guest today is Francis Collins. Francis is the director of the National Institutes of Health, NIH, the largest supporter of biomedical research in the world. Francis is a physician-geneticist noted for his landmark discoveries of disease genes and his leadership of the International Human Genome Project. Francis is an elected member of both the National Academy of Medicine and the National Academy of Sciences, and was awarded the Presidential Medal of Freedom and the National Medal of Science. In 2020, he was elected as a foreign member of the Royal Society and was also named the 50th winner of the Templeton Prize, which celebrates scientific and spiritual curiosity. Francis, welcome to the show.
Glad to be with you, Glenn. Curious to know where we're going with this, but I guess we're starting down this journey. Let's see what happens.
You and me both. So I'll tell you actually where I want to kick things off, which is, I have to imagine, with what's on everyone's mind these days, of course, which is COVID-19. And, just to go back, pretty soon after we had identified this as a global pandemic, you would put together under the NIH this emergency public-private partnership representing academia, government, and industry to collaborate on a shared mission of discovering a vaccine. And my gosh, you did so in record time. So if the math is correct, from the day we identified this virus as a global pandemic to the day we got a vaccine FDA approved, this was less than a year.
That's right.
I mean, that's just extraordinary, isn't it?
It is extraordinary, about 5 times faster than has ever happened before.
I imagine if we tried to unlock the mystery of how that happened so fast, we could easily take up half a day. I know that's not the first time you've built these really incredible global coalitions, but what was the sort of magic behind accelerating this process and getting this through in such a rapid fashion?
Well, there are a lot of parts to this, Glenn. The first part, of course, was having the technology of messenger RNA as a new way of making a vaccine, which turned out to be really efficient and made it possible to move really quickly, but had never been successfully applied to a human vaccine before. People might think, therefore, that we just sort of made up the idea in January of 2020 and thought, well, let's try this. But actually, it was 25 years of hard work that went into figuring out that this approach could be successful for an infectious disease and priming the pump, as it were, to be ready to plunge right in. And that's a credit to the scientists working in the Vaccine Research Center at NIH, who had been exploring this, thinking they might need it for SARS, or maybe they might need it for MERS. And then here came this other coronavirus we now call SARS-CoV-2. And there we really needed it, and needed it in a hurry. So that was a big part of it, was having that technology ready to go, which could be started as soon as the Chinese scientists put up the letters of the code of the viral genome, just A, C's, G's, and U's. You knew exactly how to design the vaccine and get started. That was great, which meant that within 63 days, the first patient was being immunized in a phase 1 trial. And that is breathtaking also in terms of the shortage of the timetable between when you knew you wanted a vaccine and when you actually had somebody rolling up their sleeve. But of course, that's a start. By then, this was March, we knew that we were going to need to ramp this up to do the definitive trials to demonstrate whether this is safe and effective. And if it happened to work, to be sure that there was manufacturing capability to have millions of doses ready to go as soon as possible. And that was also unprecedented, to try to coordinate all those things at once. This partnership that you mentioned, which is called ACTIV, ACTIV, was an effort on the part of myself and some other leaders in industry to try to get all of the people who knew what to do around the same table, so that we would not waste a second, and we would design exactly how all of this should go forward. What should the trial look like? How many people should be involved? Should this be placebo controlled, where some people get the vaccine and some people think they did but didn't because they got the placebo? What kind of expectation would you have about how good the vaccine had to be in order to be worth investing in? What's the endpoint? What are you looking to do? Prevent disease, prevent virus in the nose? All of that had to be worked out, and was very quickly worked out by this partnership that ultimately involved 20 pharmaceutical companies, the NIH, the FDA, the CDC, BARDA, which is part of the government, as well as the Department of Defense, and all managed by a very careful program management, skilled set of individuals in the foundation for NIH. And it was my job as co-lead of the executive committee of this, along with Paul Stoffels of Johnson & Johnson, to make sure it all happened.
Wow. It's honestly one of many incredible accomplishments. Certainly I would rank them up there with many others. Was it frustrating? I shouldn't say was in the past tense, still ongoing. We just, I think as of yesterday, surpassed 500,000 deaths. And look, it's a pandemic. People are going to die, but there didn't have to be that many. And I shouldn't even say this with such a US-centric view, because clearly there are a lot more than 500,000 deaths. But just here, domestically, is that just frustrating to be sitting where you sit, knowing that there were so many not too strenuous measures people could take, and we just couldn't all collectively galvanize to do what needed to be done?
It was frustrating, but mostly it was just heartbreaking to see the devastation that this pandemic was creating. And some of that we could not have prevented, but some of it we could have. And yet there was such a mixed set of messages coming out to the public, and such an unfortunate political overlay in many of those messages, that we lost opportunities to stem the spread of this disease in ways that we could have. And the consequences of that, as we now grieve for the loss of 500,000 people just in the United States, are almost impossible to get your head around. Yeah, we, looking back on this, did not really do what you would have thought the most technologically advanced country in the world would have done, which is to look at the evidence and then immediately implement all the appropriate public health and science measures. And even today, we don't seem to have fully succeeded in getting the facts in front of everybody to the degree that those actions are being taken. Yeah, that I don't know that I quite expected, that it was going to be this hard to take what we know and get it put into practice. Admittedly, we learned along the way, and I think that probably added a bit to the confusion. Nobody really expected in the first month or so of this viral illness that there would be such a significant factor from people who have no symptoms and yet are infected and very capable of being super spreaders. That's not the way respiratory viruses are supposed to behave. Mm-hmm. And so the whole idea then that became more and more compelling in the spring, that everybody should be wearing a mask, was built upon that realization of the asymptomatic viral spread. But I'm not sure everybody got that. And it started out being much more of a concern that masks were needed by the healthcare providers, and so we shouldn't be rushing to have everybody wear one. And then we began to realize, oh yeah, for this disease, we need to do that. And people still look back on those mixed messages as if somehow the scientists don't know what they're talking about. Well, we learned that's what science is. Yeah. You start with an understanding, you collect more data, you may change your view as a result of data. You should change your view as a result of the data.
Well, look, I mean, I want to be optimistic, and I feel like I can finally start to see a tiny sliver of light at the end of this dark and narrow tunnel. But it feels like every day there's all these doomsdayers who say there's more and more variants. We'll never get it under control. Half the country's not going to want to get vaccinated because they don't believe in vaccinations. And we're going to have to live with this virus or some variant of it for years and years to come. So I guess the question, Francis, is do you feel optimistic at this point?
I do. That's my general tendency. People who have known me for many years would say when we get into a discussion about what's possible in terms of a medical question or a scientific question, I'm tending to be on the part of the spectrum that says, yeah, we could do that. That could work. So yeah, by nature, that's where I am. And I do think there's a lot that we can look at right now and feel optimistic about. My goodness, the fact that we have 2 vaccines that have been given FDA emergency use authorization and a third one that is being considered this week for possibly being added to that list. That's amazing. We should never have had the expectation of getting this far. And that the first 2 didn't just turn out to be okay. They had like 95% efficacy. Few vaccines have ever reached that kind of level. So, wow, we have some amazing tools in the toolbox. And I can also be optimistic when I look at the trajectory in the last month or so of what's happening in the United States after a devastating peak of terrible instances of cases and hospitalizations and deaths. We are seeing a rather steep decline in all of those measures, not down to where I would want it to be, but the slope of the curve is certainly really encouraging, suggesting that for whatever reason, maybe it's that people are being more adherent to public health measures. Maybe it's the vaccines are starting to help, although it's still early to expect much of that. Maybe, as some people have suggested, we even have now enough of the population in some places that have had COVID-19 to begin to have some of this herd immunity that's much talked about, although it seems early for that as well. Whatever the reason is, we seem to be on a slope that I like a lot better than where it was a month ago. And as far as these emerging variants, which is something NIH is intensely interested in, so far, there are none of them that I am concerned would make our current vaccines not successful. One watches closely. The South African one in particular may make the vaccine slightly less potent, but it should still be good enough. And now let's make sure we don't have too many others emerge. So everybody, let's put your masks on and watch your distance and try not to have too many viral replications happening.
Yeah. So look, I know you don't know definitively, but if you had to venture a guess when it will be safe to go back into restaurants without a mask, be together with family and friends and live life, quote unquote, normally once again, when would you say?
I don't know, but I would say I'm looking forward to the chance of going to a baseball game this summer. Maybe not at the beginning of the season, but sometime during the season. And I'm looking forward to the chance of being able to be with my grandkids and not worry about it. And I'm even hoping that at NIH, where we have so many people who have been pushed away from the lab bench where they want to be, that we'll have most of those people back at work doing what they do so well.
Okay. So let's talk about young Francis.
Oh, him.
Not that you're not young now. Let's talk about younger Francis. So your parents, and I hope you'll forgive the term here, but for lack of a better word, were sort of hippies. Before there was such a thing.
Mm-hmm.
They eschewed business. They bought a farm in rural West Virginia. They founded an outdoor community theater in the woods, like in your backyard. And then your mother had homeschooled you until the 6th grade. And no, we're not talking the 60s. So what are your memories during that period of time?
Well, it was just a wonderful way to grow up. They had already had a lot of life experiences before I came along. I'm the youngest of 4 brothers, And I'm not sure my parents were quite expecting that there was going to be one more, but there I was. And by then, they had already worked for Eleanor Roosevelt during the Depression in West Virginia. They had lived in North Carolina, where my father became a folk song collector and was one of the most notable contributors to the Library of Congress in the American folk tradition. They had, during World War II, moved to Long Island, where my dad became an efficiency expert in building bombers just because he was a smart guy, even though he had no training in that area. And then moved to this farm in the Shenandoah Valley where I was born to basically have the kind of life that they dreamed of, which was to pursue theater, music, the arts, live off the land, not very effectively, and raise their four sons in a way that allowed learning to be a joy and not some drudgery that they perceived would happen if you were sent to the local county schools. Hmm. And what a gift it was to grow up that way.
And I think you performed in some of those plays at the community theater, right? Was that maybe some of the foundational experience to learn the art of communication?
Absolutely. And that is a wonderful opportunity for people who have had that experience. Yeah, this summer theater that my parents started when I was 3 years old is still in its every consecutive season other than COVID, still runs 5 shows every summer in an outdoor theater with fantastic actors and producers, all from the local communities. And when I was growing up, there would be at least one Shakespeare play and at least one musical and maybe a Noel Coward or a Neil Simon or something like that. And if there was a role for somebody my age, boy, I wanted it. And it was joyful to be there. And as a small theater, you could see the audience. You could tell whether you were connecting or not. And that's not a bad thing to get sensitized to if you're going to be a teacher or a scientist who's called to communicate.
Well, I know faith wasn't an important part of your childhood, and you would become in your early years an agnostic and then later on in college an atheist. And I'm guessing, and you can correct me here, that your parents weren't exactly religious zealots themselves. So was that the influence early on why you just sort of looked the other way?
Yeah, they didn't emphasize faith as having any particular significance in their lives. And I guess I followed that same model. My dad thought it would be good for my brother and me to go to the local Episcopal church to sing in the choir, to learn music, which I did. And that was a wonderful gift. But the theology seemed very muddled and I ignored it, which is what he suggested was the best approach. So I had no foundation of any real understanding of what faith or theology was all about. And as a guy who was really interested in science, chemistry, physics, I was a reductionist. And the idea that there was something outside of what science could measure did not seem at all appealing. So, yeah, I slipped from being an agnostic, although I'm not sure I knew the word at the time, into being an atheist who would not have probably been very friendly if you told me you believed in God.
Well, speaking of science, you when you were done with the homeschooling, you attended public school. And somewhere along the way, you had some charismatic chemistry teacher who had inspired you to pursue a career in science. Do you remember what you found so captivating?
I do. Yeah, his name was John House. He taught 10th grade chemistry at the public high school that I was fortunate to attend. And the very first day of class, he tried to convince us what science was really all about with a simple metaphorical experiment. We were each given a box. It was actually a black box. And inside it was something, but it was all taped up. And we were supposed to think of all the experiments you might want to do and even try to do some of them, although in a limited public school laboratory, there wasn't much, to try to figure out what's inside. And spent the whole hour just really trying to dream up of the kinds of things. If you had all the equipment in the world or things that you could design that didn't exist, what would you use? And then ultimately at the end of the hour, you got to open the box. There was a candle in my box, by the way, and I had not figured that out. But what an amazing way in the very first day of a science course, it was really going to be about science, not descriptive science, not memorize the parts of the crayfish, which I hated, but actually it's a detective story. That's what it is. And you use these amazing tools that are coming along and you investigate things that were not known before and you can figure them out. And yeah, sometimes, like a detective story, you get it wrong. You go down a blind alley or your clues turned out to be misleading. But ultimately, there's such a thing as truth, and science will lead you to it if you're persistent and you use the right tools of rationality and logic. And that was like, that's what I want to do. That is exactly the kind of thing I could spend my life on.
Yeah, well, just to fast forward a bit, you went on to earn your PhD in physical chemistry at Yale, studying quantum mechanics. But then shortly thereafter, you sort of shifted course and went to med school. And then you earned your MD a few years after you had gotten your PhD. It's sort of a shift in direction.
Oh, yeah.
You know, that's a lot of years of pretty intensive study to get a PhD, of course, just to sort of toss aside like that. Why the 180? What was behind that?
You know, I was a high school student, 2 years younger than my colleagues. Again, because my mother had taught me, I ended up being 16 when I graduated from high school. And I first encountered chemistry when I was 14. And it was the first science that I really got into. And I figured, this is it. And hence, in college, majored in chemistry, went on to graduate school, as you just said, and physical chemistry. Kind of didn't look around that much to see what else was going on in science that might be just as appealing. And particularly, I avoided biology because it didn't seem like it was very much organized around principles. The biology I had seen was really memorization, and I didn't find that interesting. And what happened was when I was in graduate school at Yale, I finally realized I might be missing out on something here. There are people around me in the Department of Chemistry who are studying this molecule called DNA. And it looks pretty interesting and it's almost mathematical. And gosh, there are principles here about how life works. It's not just a muddle. So I took a course in biochemistry and genetics, and I was totally hooked. I said, how did I miss this? At the same time, while I was enjoying my second order differential equations and quantum mechanics, it was pretty clear to me that was a path that was going to lead me pretty much exclusively towards a university professorship, doing some research, teaching undergraduates thermodynamics and statistical mechanics, which most of them would either hate or be terrified by. And it wasn't clear to me that was quite what I was hoping to spend my life on, even though I greatly enjoyed the science. And it just seemed like, okay, I'm getting a call here to change fields. How do I do this? Oh my gosh, I'm already 2 years into a PhD and I think I want to do something different. And going to medical school was a radical step because I was already married. I already had a small child, but it ultimately seemed to me to be the best way to keep all of the opportunities open. Having narrowed prematurely, I wanted to open up all the way. Mm-hmm. And medical school, well, yeah, maybe I'll just love being a doc and I won't care about research. Or maybe I'll actually love being a doc and I want to do research and I'll now have the background to do that. So there I went off to the University of North Carolina to try to learn how to be a physician. And in the very first couple of months, I knew this is what I was looking for. And this is science. It's elegant. It's amazing. Look at the human body and how complicated it is, but it matters. And there's stuff happening here that maybe I could contribute to that might help somebody.
Well, what I found interesting is I think it was either during your medical studies or maybe shortly thereafter, in residency, I believe through a number of interactions with some of the patients, you began to start to question your own atheistic convictions. And you ended up reversing course on that and becoming a man of faith, becoming a devout Christian. Can you sort of walk me through the transformation? Like what happened? What did you see? What did you hear? What did you feel?
Yeah, I wasn't counting on that part. But yeah, when I got to medical school, I was aware there were some medical students around me who were people of faith, and boy, did I avoid them because I didn't want to have to talk about that. Maybe because I was aware at some level that I hadn't really given that much consideration. And it was a patient, an elderly woman who I was taking care of as a senior medical student who had terrible heart disease and was having really awful chest pain almost daily. but for whom her faith was a heck of a lot more important in terms of providing her with comfort than what we in the medical profession were doing. And she was very free about sharing that. And I was touched and puzzled. And then one afternoon, she turned the tables on me and she said, doctor, I have shared with you my faith and you never say anything. What do you believe? 4 simple words. What do you believe? And it just hit me so strongly that I didn't have an answer to that. I hadn't spent a fraction of the amount of time that it would take to even begin to scratch the surface of what the right answer to that might be. Because I had to admit, the whole thing made me uneasy and uncomfortable. And it made me uneasy and uncomfortable again when she asked, but I couldn't run away from it without it haunting me that she was right. This was probably the most important question I'd ever been asked. Maybe the most important question any of us would ever be asked. What do you believe? And I had no answer. And I was a scientist, right? I was supposed to be a guy who approached important questions by looking at evidence. And I had assumed there wasn't any in this case when it came to faith, but there were, after all, people around me who seemed otherwise pretty well put together, who claimed to believe in God. So there must be something there. Maybe if for no other reason than to support my atheism, I'd better do some exploration here of exactly what is the evidence. And that's where I began down a journey, which maybe I thought would take a few days, but actually took about 2 years and ultimately led me not to where I thought it would, but to an embrace of faith, and specifically of the Christian faith, as, for my perspective, the most rational of the choices when you considered all the evidence. And that shocked a lot of people, including me.
And so did it sort of happen overnight, or was this over the period of years?
It was a 2-year journey of up and down, initially just trying to understand, well, what is it that people believe when they say they do? And how can you possibly accept the idea that God could be a reality when you have no way of measuring that? Because I was coming at this from what would be called metaphysical naturalism, that nothing is worth considering unless it can be measured scientifically. And after a while, it became a little clear to me, wait a minute, if God does have any meaning, God cannot be entirely contained within science or within nature. What the God that I understand people are talking about is actually beyond those limits. And so I need to stop with the argument that science has to show me the proof. I did begin to realize, though, that science was showing me some interesting pointers towards the idea of a supernatural capability outside of what I could measure, and the Big Bang being one of those. Okay, what happened before the universe came into being? That's a hard question to answer unless you postulate something that's outside of space and time. And then when you start looking at the way in which the universe is put together, I kind of realized those second order differential equations that I loved so much. Why do they work? Why does mathematics work so well to describe the truth of matter and energy? There's no reason that should be. Kind of looks like there's an intelligence behind this somehow. And then even more strikingly, the realization that the way in which matter and energy behave in our universe rests upon an incredibly improbable circumstance where you have these various constants like the speed of light, the mass of the electron, the gravitational force. You can't theoretically predict what those values should be. They just are what they are. And if they were off by 1 part in a billion, the whole thing wouldn't work anymore. It's not just that we wouldn't recognize our universe. There would be nothing interesting about it. It would be particles perhaps flying apart indefinitely or crashing back together in a big crunch. There'd be no way for anything resembling complexity to occur. It is that fine a precise tuning that seems to be the case. You can't look at that and say, well, it's just a coincidence. Either you have to say that is intentional, the dials were set here, Or you have to say, as atheists would when faced with this, that there must be an infinite number of parallel universes that have different values of those constants. But of course, we're here, so we have to be in the one where everything worked. But of course, you'll never be able to observe those other parallel universes. That's a hypothesis. So which hypothesis is less plausible? I kind of got hooked on that. So that's not a proof, but certainly if you're willing to kind of open your mind to the proposition that God might exist, this is tipping the balance a bit in that direction. And then more and more, I began to realize there's another part of this that I don't understand that seems really important, but might be another pointer. And that is this nature of humanity through every culture that's ever been described, which is that we have a sense of morality, that we have a sense that there's something called right and there's something called wrong. Our culture will determine what we put in each of those categories, but we don't disagree that there are such categories. And we feel called to do the right thing and guilty when we do the wrong thing. And evolution can get you partway there, but it's really hard to see how it explains the fact that we feel so strongly that good and evil are not just evolutionary byproducts, they're real. And that's a hard one for an atheist to be able to explain away. If you want to be a strict atheist, you have to say good and evil are not really concepts that have any meaning. We've been hoodwinked by some sort of evolutionary pressure, and so we ought to just shrug all this off and go about doing what we damn well please. And yet nobody feels like that's something they can do or would do or should do.
Because you're saying we wouldn't have a sense of morality if there wasn't a greater being out there.
Exactly. That's a hard one to get your head around, but it certainly got to me. And if I was looking then for evidence, not just of the deist kind of God that created an interesting universe and then went off to do something else, but a theist God that cares about me and other human beings, well, what did I just find here? This moral law, as C.S. Lewis calls it, written within my own heart that I do a poor job of living up to, but I know it's there. That's a pretty interesting pointer as well. All of this I'm now describing in 10 minutes, but it took 2 years.
Yeah, I know it's a much longer conversation. Is it true that you wake up, I think, 4 a.m. every day to pray?
Yeah, usually it's more like 4:30 or 4:45.
Close enough. So I don't want to be too intrusive, but could you maybe share when you pray, is it, thanking God for good things in your life, or is it praying for help like, gosh, I hope we can end this pandemic and things like that?
It's all of the above. It's basically trying to get in tune with whatever it is that maybe God would want me to understand beyond where I am at that point. Maybe I'm struggling with a decision and I'm not quite comfortable with the way it's going. Some of it is being thankful, because we can get so tied up in the stresses, especially right now, that you forget to stop and say thank you for all the blessings around us. And some of it is, frankly, I know I've done something I'm not proud of, where I was short with somebody, or I basically made a decision that was maybe a little more self-serving than it should have been. So some of it is confession. And then it's also, okay, I need help for today. I need to be grounded. I need to be ready for whatever comes along, so that I'm not anywhere other than where I should be, as far as being a loving, objective observer and decision maker of whatever I'm called to do today. So get me there.
Hey, everybody. Okay, just wanted to share a new podcast that I discovered. It's called Leadership on Purpose, which is about growing your influence and helping you lead with confidence and humility. This one's hosted by Blake Bozarth, a leadership advisor who founded CoThrive, and this podcast to develop mission-driven leaders to unlock the potential of their organizations. It features top execs distilling their wisdom on a range of topics. A few of the ones that I listened to recently are about servant leadership, creating a mission-driven culture, scaling a team, and leading transformations. Think of it as leaders building future leaders. I'm a leadership advisor myself, as many of you know, and I've learned quite a bit listening to Blake's podcast. You can find Leadership on Purpose on Apple Podcast and Stitcher. Okay, I hope you enjoy it too. And now back to the show. Okay, I'm going to pivot off religion so we don't spend the rest of but it is a fascinating topic. You went on to University of Michigan, became a professor of, I believe, internal medicine and human genetics.
Right.
And you developed this technique known as positional cloning for identifying genes. And with that, you would discover the gene responsible for cystic fibrosis and I believe Huntington's disease, among others. So can you explain in layman's terms, what was this technique and why was it so seminal in the field of human genetics?
Well, it was an effort to try to really get to the bottom of what is the misspelling in DNA that causes diseases like cystic fibrosis and Huntington's disease. We knew because these were inherited in families in a certain way. Some are the recessives like cystic fibrosis and some are dominant like Huntington's disease, that this must be due to some kind of a glitch in a gene that normally does something really important. And when it's misspelled, the consequence happens to that person. But for most of the genetic diseases that we could describe in terms of their inheritance, we had no idea what gene was actually involved. And back in the 1980s, before there was a genome project, it was all pretty much uncharted territory. So how would you then actually find or clone, as we said, the responsible gene for cystic fibrosis when you have no idea what you're looking for? And basically think of the genome as an instruction book, a very large one with 3 billion letters. And somewhere in that 3 billion letter set is a misspelling that contributes to this particular disease. And how do you find it? Talk about a needle in the haystack. Well, you start by studying families because you can then look to see who in the family has the disease and who doesn't. And you can track with other bits of DNA that are scattered across all the chromosomes. Are there any bits of DNA that are pretty good at predicting who got it and who didn't? Because if you see that, that means it must be close by to the actual responsible gene. It must be on the same chromosome. It must actually be fairly close on the same chromosome. So that's how you get started. And that is sort of where things were for most diseases in the mid 1980s, but you're still dealing with a huge stretch of DNA letters and finding the responsible one becomes a major undertaking. And that's what we had to do for cystic fibrosis, is basically walk across millions of these letters looking until all of a sudden one day, there it was, just 3 letters missing in people with cystic fibrosis. And that had to be the cause. And that was then the positional cloning of the cystic fibrosis gene.
So to continue on this genome journey, you later on became the director of the National Human Genome Research Institute, which was the organization which oversaw the Human Genome Project. I think a lot of people are familiar, but not everybody. So this was the global consortium which sequenced the entire human genome, which entailed sequencing some, I think, 3.2 billion base pairs of human genome, which is just hard to even process. You know, it is one of the biggest, most monumental scientific breakthroughs ever. I think it was once thought impossible. I don't know, Francis, honestly, that I'll ever truly understand the gargantuan challenge that was behind it. But can you just try to convey to me the complexity of what was entailed to do that?
Sure. Well, first of all, there was the motivation. We just talked a minute ago about finding the cystic fibrosis gene. That took the better part of a decade, took many groups, many of whom basically fell along the way because it was just too hard. And that was supposedly one of the genetic disorders that ought to be the easiest because it's fairly frequent. We knew there were thousands of other genetic disorders, as well as the sense that probably cancer was a problem in DNA. And if we didn't really have this basic reference sequence of the human genome, we were never going to sort this out. So the reason to do the Human Genome Project was intensely clear, but there were lots of people who thought this is never going to work. When the project started, a really good lab might be able to read out in a day a couple hundred letters of the DNA code. That was a good day. And we're talking about 3 billion. So it did seem maybe this is a bit of a stretch and it's going to fall flat. And I certainly, in the early days of this, trying to build the teams to do this, had many occasions where I thought, boy, the day will come where I'm going to have to make a public statement that this was well-intentioned but doomed. But it began to work. It began to work because it was such an appealing, historic kind of opportunity. And so some of the best and brightest young scientists, even though they knew it was risky, said, I want to be part of that. And it was clear it had to be international. There were 20 labs involved in 6 countries that ultimately got this done. It was my job to try to coordinate all of that, which wasn't always easy. But people stopped worrying about who got the credit. They just wanted to get it done and get it done right. And the quality of the data had to be really good. And by, 6 or 7 years into this supposedly 15-year project, I began to believe it might actually work. Ultimately, the technology got better and better. And maybe it's proof of the same thing that most people in the private sector will tell you, that 90% is getting ready to produce the product. Then you're ready to go. And most of the human genome was actually sequenced in about 18 months. And at that point, we were doing 1,000 letters a second, 7 days a week, 24 hours. Quite different than doing 100 in one day when we had started.
Well, just to back up, because you sort of glossed over the coordination part of it, which is a big piece of this, right? This is you leading an international team, like you said, 20 organizations across 6 countries. So what's your role as a leader when you're overseeing something like that?
It started out being to design a program that had all the right pieces in place and supported with the funds that Congress gave us at an appropriate level. So a lot of it was technology investment. We knew we didn't have the ability to do this unless somebody invented better ways. That was a lot. Then it was basically trying to get the essential factories set up to do the sequencing in a way that had never happened in life science before. This was a completely departure from academic biology. And that meant finding people who were willing to do that and continually pushing them and trying to make the most of the fact that this was a collaboration, but a little competition is not a bad thing. If you have some groups that are actually beating their deadlines, maybe other people will start to feel like they should too. Then setting very high standards for the quality and the completeness. It wasn't going to be good to say, we finished the human genome, except for part of chromosome 9. So everything had to get done, and that meant making the assignments and then readjusting if somebody fell behind. A lot of this was organizational efforts. I still, on Fridays at 11 o'clock in the morning, I think, oh my God, it's time for the genome conference call, because that was it every week. And I would set the agenda and we'd try to make it sort of a lab meeting. So somebody would present some new technology or some new observation. But then most of it was, okay, let's see your production for this week. Let's see where we are, who's on top of things and who's having a problem, and let's adjust accordingly. I had no training to do this. Before I came to NIH to run the Genome Project, the biggest thing I'd run was my research lab. So I'm sure I made lots of mistakes along the way, but we all learned together.
So I'm going to bring that human morality back into this this next topic here, because on the heels of this incredible human genome sequencing, years later, they would develop a revolutionary gene editing technology called CRISPR, which, of course, can be a double-edged sword, because the technology which allows us to identify and remove the genes which give us certain diseases is the same technology that could be used to produce humans which are smarter and taller and better looking, all of which my wife would love for me to have. But, given your theocentric views, I'm sort of curious about what you think of scientists now having the toolkit to essentially play God. Like, do you feel we've crossed some sort of sacred line? And I guess on that note, how do you even decide where the line is? It's such a slippery slope.
Well, it's a great example of how science can produce knowledge, but the way in which you apply the knowledge is where morality and ethics kicks in. And we've known that in other circumstances. Goodness, learning about nuclear energy, we have figured out ways to do great things with that. I mean, in the hospital, when somebody's having some kind of a scan that depends on understanding nuclear energy that may end up finding something that's going to save their life, that's great. But if that nuclear energy is being used to make a bomb that's going to kill hundreds of millions of people, that's evil. It's just the knowledge, but it's the ethical application. Biology has those same experiences, and the one you mentioned, gene editing, is, I think, foremost in many of our minds right now. It is an incredible set of scientific developments recognized by the Nobel Prize to Jennifer Doudna and Emmanuel Charpentier, that it is possible with a fairly simple system that works really well to essentially do find and replace in a genome, just like you would on your word processor. I would not have guessed that something that elegant and that error-free was going to happen in biology. But there it was, and thanks to nature, because we stole it from bacteria that had figured out how to do this to protect themselves against invading viruses. And to find that that same system could be adapted to virtually any living organism meant that suddenly things were within reach that we did not expect to be able to do. I will be the first to say that I think this is one of the most exciting and potentially wonderful developments for genetic diseases that currently don't have a treatment. I'll give you an example. My lab works on the rarest form of premature aging called progeria. These are kids who appear normal at birth, but they age at about 7 times the normal rate, and they die about age 12 or 13 of heart attacks and strokes, looking like little old people, even though their brains are normal and they've developed as children. Their lives are cut short. This is due to a single letter that is misspelled, a T that should have been a C. We discovered that back in 2003. And gene editing seems like it might be a really good way to treat one of those kids with that disease. If you could deliver the editor to the appropriate cells in their body and just fix the mistake, that would be a noble thing to do. We have just published a paper a month ago doing that in a mouse model with a single intravenous infusion of this CRISPR gene editor, and the mice extended their lifespan by 3-fold, almost to the point of looking like a normal aged mouse. And we're on the process now of trying to figure out how to bring that into a human clinical trial. So I would say there's nothing about that that seems to me to be particularly ethically fraught, other than you'd want to be sure you understand what might be unexpected side effects and be sure that that's included in any clinical trial that you're offering to volunteers. The place where the problem arises, of course, is not that situation where you're treating somebody who's already walking around. It's when you're planning to rewrite the genome of an embryo or a gamete, a sperm or an egg, something that's going to be transferred to future generations. And this is where I am deeply concerned about potential uses of gene editing if it's in the heritable part of the genome. First of all, there are few situations where you can really look at the need for that and say it's compelling. And we could get into why that is, but it's very hard to identify a situation where you need to do gene editing in embryos in order to do something about a medical problem. Second of all, if you were going to contemplate allowing this kind of action to occur, in what situations would you say it's okay, and where is the limit? It's obviously going to be tempting for people, maybe including your wife, to say, let's try to have a child that's got optimal characteristics as compared to what we would bring to the table naturally. And frankly, mostly we don't know how to do that. The kinds of things people might want to optimize are incredibly complicated genetically and have a huge environmental influence. But it also suggests that somebody is going to decide what's an improvement. That means that will bring certain prejudices to the table about what's a more appropriate specimen and what's not, and that sounds pretty prejudiced. But most fundamentally, for me as a believer, as somebody who thinks that God had a plan for the human species, we would really be stepping in to a space we have not previously occupied, where we're going to redesign our very essence and become perhaps a post-human species. That feels really outside of the boundaries of what I think, as a Christian, I believe God has called us to do. Yes, sure, do everything you can to support people who are suffering, to promote healing, but to redesign your very species, to improve yourselves on the basis of some heritable technology, that feels like a line we should not cross. And I've been very public about that. And by the way, I'm in the majority by far, not just of people of faith, but people who have almost any perspective. This would be the majority view.
It sort of strikes me that you've got this somewhat unusual combination of abilities. You're this highly regarded, brilliant scientist on the one hand, and you're also this world-class leader on the other. And for those that don't know, the size of NIH, which you've been overseeing now for 3 administrations, this is the largest biomedical research institution in the world. 20,000 employees, I believe, $40 billion research budget. So the scientist and the leader, not to stereotype, but these are typically two very different archetypes that you don't always find in the same body. So I don't know if you ever thought about that, but just curious, how you would explain that.
I'm not sure I can. I guess I have to think of this as having been incredibly fortunate to have these opportunities come in front of me that I never planned. I mean, thinking back, we were talking a bit ago about growing up on that farm in the Shenandoah Valley, loving being on the stage and learning how to play the guitar. And the idea, first of all, that science would be part of my life certainly didn't occur to me then. And certainly the idea of becoming a scientific leader in charge of an organization like NIH, I would have laughed out loud if somebody had so much as suggested that. And everybody around me would have laughed too. It was just utterly unlikely and impossible. I can't claim any particular cleverness in having traveled this pathway. A lot of it, and maybe this is something for everybody listening to think about too, is just as you go along your life, don't imagine that you can somehow map out all of the chapters and what's going to happen, because maybe that was once the case, but it's sure not the case now. And then you have to figure out, when a door opens that you didn't expect, do you walk through it, or is that one of those to say, that's probably for somebody else, but don't immediately reject it. When I came to run the Genome Project, I really struggled with that because I thought it was probably going to fail, and I had to be a federal employee and all these things. It just seemed like, wow. But there was only going to be one Genome Project, and if this was something that I could play a role in, well, okay, worth the risk. So every door that opens, it's like, what's the risk here? What's the opportunity? Is that one to pass by? The hardest ones, though, are the ones where you're really sure that this is what you're supposed to do, and then that door slams on you. And those take you some while to pick yourself back up. That's where I think faith is really helpful to me, is when you have those disappointments, you have something to fall back on to say, it's just not all about what happened today. There's something much bigger in this story. That part I can hang on to even when I've had a bad day.
Yeah. You mentioned music and playing the guitar, which I know is a passion of yours.
Yep.
It was big in your household growing up, and I think I read that even to this day, you open your house and have friends come over and do these late night jam sessions, which I think is really cool.
Yeah, I miss that with the COVID. We've not been able to do those house parties. Oh,
I know. Again, we're plowing through the tunnel. What does music do for you? What is it something that's emotional? Is there something spiritual about it, or is it just sitting back and listening to good old tunes?
It's all of that. Music itself is so powerful just in terms of the beauty of the experience. That is, when it goes well. Doesn't always turn out that way, but a musical experience does something to lift you out of whatever you're in the middle of, that makes you feel joyful and or sometimes makes you feel heartbroken, depending on the music and the setting. But it gets to you. You can't be a completely reductionist person and experience music the way most of us do. And for me, sometimes I get so deep into the weeds of what's happening in my daily experience trying to run NIH in the midst of a pandemic, that it just really helps to step away from that and immerse myself either in listening to some powerful, maybe it's a flat picker or maybe it's Beethoven, but something that just gets right to my soul. Or maybe it's sitting down at the piano, which I often do when I need a break, and just seeing what happens and trying to have that more creative, improvisational part of my brain has a chance to do something. And then I feel enlivened by that. But it's also spiritual. I mean, I think this is a place where whatever spirituality is, somehow music can get you in touch with that. When I think of some of those moments in my own life where I felt most inspired as a spiritual being, there was often music involved.
I know we've barely scraped the surface with your career and what you've done. I mean, you've had so many accomplishments, so many accolades over your lifetime. It's like 6 lifetimes in one. So when you look back, what are you most proud of? Is there any one thing that stands out?
Oh boy. Well, we haven't talked about family, but I'm awfully proud of my 2 wonderful daughters. One's a physician, one's a social worker. They have given themselves to others and not really worried too much about getting the accolades to themselves. And I'm really proud of how they have done so. Scientifically, I guess it'd be hard to go a lot past the Human Genome Project as something that felt pretty significant, pretty historic. But I have been so fortunate in other ways. And the moments that have been most meaningful are when it seems like a person has been touched by what's been done. I'm a physician. My dream has always been that science would not just be a academic exercise or that detective story of the black box in the chemistry class, but also something that touched somebody's life for the better. And so when I see vaccines now going into arms that are going to save people's lives from COVID-19, and that I feel like I had something to do with that, that's making me feel pretty good about having spent this time.
Yeah, you played a big role in it, no doubt. So if you were looking into your crystal ball, what's the biggest discovery over, let's say, the next 20, 30 years? What's the next big breakthrough? It doesn't mean coming from you or NIH, but just what's yet to be solved that you think is pretty solvable in a reasonable amount of time?
Maybe I'll come up with 2. One is in basic science and one is in application. In basic science, I think it will be understanding how the brain works. We are in the middle of exploring that in a very intentional way. And it's clear this is really an incredibly complicated, difficult problem. It makes the Human Genome Project look really simple. You have 86 billion neurons between your ears. Each one of those has about 1,000 connections. This is the most complicated structure in the known universe. And we aim to try to sort it out and understand how those circuits do the amazing things they do, and then how to apply that to help people with a very long list of disorders, from depression and schizophrenia to Alzheimer's disease and seizures and everything else. This is going to be, I think, one of those frontiers that we could cross in the next 20 or 30 years with profound consequences, and including a lot of ethical issues that will find their way in there as well. If we learn how to actually download memories and apply them to somebody else, that could be pretty, sounds like Hollywood science fiction, but it might not be. So that's a big frontier that I think anybody who's interested in science, neuroscience is going to be a pretty wild place to be.
Okay.
In terms of the other solution, I have a passion about seeing something done about health inequities, and both that's domestically and globally. In our country, and this has been so clear, especially in 2020, with the recognition that We are still in the United States seeing the consequences of 400 years of racism, and that has affected our healthcare system in ways that cause many people not to get the kind of care they need and deserve, and that it's even affected the way we do research. NIH needs to redefine some of our goals in the knowledge of this reality. But part of that also is not to be so narrow, is to think about health inequities as just a US problem. It's a global problem. I care deeply about the fact that so many people in our world don't have access even to basic necessities of health and don't have the chance to live out a life that's free of terrible illness or premature death. Having volunteered a few times in a missionary hospital, I just feel like there's so much more we could be doing in that space. And so my hope would be that we actually figure out how to do those things. The resources are not necessarily the limit. It's going to have to be the determination to stand outside of our own self-interest, or maybe to realize that our self-interest is best served by being sure the whole globe is taken care of. Okay, that's pretty bold, but
yeah, no, because I think you had served it. Weren't you like in Nigeria or something many, many moons ago?
Yes, I learned a lot from that by being a volunteer doc in a jungle hospital and realizing just how fortunate we are, even though we complain all the time about our healthcare, and also seeing the opportunities there. It wouldn't take that much to transform the way in which healthcare is received by people in lots of other parts of the world.
Yeah, life is definitely relative, that's for sure.
Yeah.
So, Francis, I always wrap up with this question. The podcast that you're on right now is called The Art of Excellence.
Oh, yes.
So that word excellence, what's the word mean to you?
Well, I guess it means being outstanding, being really good. But, it probably carries more with it than just that kind of comparison to other efforts that maybe aren't quite as good. It seems like it also ought to carry with it some moral character. We're coming back to morality. Mm-hmm. I suppose there's an art of excellence in being a really good drug dealer, but I'm not sure that's what we should be thinking of when we say we want to aspire to excellence. I'm sure there's an art of excellence in being incredibly dedicated cloistered nun who's praying every day. I admire that. I think that's a wonderful gift to the world that such things exist. And I think, of course, coming from science, the excellence of somebody who's just found a new way to cure cancer using immunotherapy, that's to admire. So it's not just being able to bring your best, your creative approach, your work ethic, your dedication, but also in the service of something that matters. That's excellence. There's a verse in Philippians where Paul is advising the people in the church how to spend their time. And it's something like this. Finally, brothers and sisters, whatever is true, whatever is noble, whatever is right, whatever is pure, whatever is lovely, whatever is admirable, if anything is excellent or praiseworthy, think about such things. That's got a lot of sort of synonyms, but not quite with excellence, that if we lived by that, things would be better.
Wow. Perfect. Perfect. I love it. We're going to end on that. This has been just incredible, honestly and truly, just for a few minutes here to live vicariously through all your incredible work and accomplishments. And I can't thank you enough for taking the time to being on the show, Francis.
Well, Glenn, thanks for doing your show and for the chance to chat with you. It's been a very interesting conversation, and you do a great job of providing opportunity for people to really talk about what matters.
Hey, thanks for listening. Okay, don't go yet, please. 2 favors. I ask simply 2 favors. One, if you could please download the iTunes app. You could do it on your phone. You could do it on the computer. Take 60 seconds and leave a review. It means a lot. 2, you can find my episodes on several social media sites, Facebook, LinkedIn, Twitter. Find the one that you like the most. Find the one where you tend to have a lot of friends and followers. And if you could please either share it in the case of Facebook and LinkedIn, or retweet it on Twitter, that would mean the world to me. So those are the two asks I have. I love putting together this podcast. I hope you enjoy listening to it. Thank you so much, and I will see you again next time. Bye-bye.